Lesson 60 is on the area of a parallelogram. Just to refresh our memory, the area of a triangle, remember the formula for it is base times height divided by 2. That's equal to the area. Now, remember where we get the divided by 2 is from if we have a whole rectangle and we put this purple line right through it, we actually have two identical triangles, but we only want the area of one, so that is why we divide it by 2. So then for the area of a rectangle, our formula is area equals base times height. But today we're going to focus on the area of a parallelogram. It kind of combines both the area of a square and a triangle together. Below here I have a parallelogram drawn for you. It has two sets of parallel lines. The top and bottom are parallel and the sides are parallel to each other. So you can see it has a base, it has a height, and then it just has this letter A to symbolize the side here. The nice thing about a parallelogram is, let's pretend that we're going to cut right along this dotted line here. I actually drew this triangle and it fits exactly here. If I cut that off and replace it here, and let's say I no longer have this triangle, now I have an exact square drawn. So to find the area of a parallelogram, we just take the base times the height. You don't want to ever choose the letter A. It's always going to be the base and the height. So the height's usually going to be inside your parallelogram. Let's take a look at example 1. Example 1 says find the perimeter and area of this parallelogram. Area, remember, we're just walking along the outside edge of the figure. If the bottom right here is 8 centimeters, we know then the top is 8 centimeters as well. If the side here is 6 centimeters, then we know the other side is the same length. So that is also 6 centimeters. Now we can go ahead and add all the sides. 8 centimeters plus 6 centimeters plus 8 centimeters plus 6 centimeters. If we add the 8s together, we get 16. If we add the 6 together, we get 12. Now all we have to do is add 16 plus 12. We get 28 centimeters for our perimeter. For area, remember, area of a parallelogram is base times height. Now we just have to figure out which one's our base and which one's our height. Area is equal to, our base is right here. That's 8, and our height is the up and down, but it has to have the 90-degree base. We can't use 6 centimeters as our height. We have to use 5 because of the 90-degree angle here. So our base is 8, and we multiply it by the height, which is 5. When we multiply 8 times 5, the area is 40 centimeters squared. In example 2, we are asked to sketch and find the area of the parallelogram with the vertices A, B, C, and D. Let's graph each of those vertices. A, 2, 1. B, 1, negative 1. C, negative 2, negative 1. D, negative 1, 1. Connect your vertices. You're going to find yourself with a parallelogram. To find the area of that, you use the formula that we just learned. Area equals base times height. You have to find the base and the height here. All you have to do is count between your points. So like between C and B, 1 box, 2 box, 3 boxes. So therefore the base of our parallelogram is 3. If we're looking at the height, we're going to talk about from vertex D all the way down to a 90-degree angle. We have to count those boxes. When we count those boxes, we have 1 box and we have 2 boxes. So therefore our height then is 2. When you multiply that together, you get 6 units squared. In B, we have to graph the dilation of the parallelogram with the scale factor of 3. Scale factor of 3 just means all we're going to do is multiply each coordinate and each number in the coordinate by 3. So I'm going to write the new coordinates underneath of them. A, when we multiply 2 by 3, we get 6, and when we multiply 3 by 1, we get 3. That's our new A prime. B prime, 3 times 1 is 3, negative 1 times 3 is negative 3. On C, we multiply by 3, and negative 2 times 3 is negative 6, and negative 1 times 3 is negative 3. And on the last one, we get negative 3, 3. Let's graph all of these. The first one, out to 6 and up to 3, A prime. Over to 3, down 3, B prime. C, over to negative 6 and down to negative 3. And then our last one is negative 3 and up to 3. That's D prime. Connect our vertices again. And again, we're asked to find the area of this image. So we just count the boxes in between C and B. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our base is 9. Our height, we can do the same thing. We're going to count the boxes from vertex D all the way down to this 90-degree angle. Let's count those. 1, 2, 3, 4, 5, 6. So therefore, our height is 6. When you multiply those together, our area then becomes 54 units squared. In C, it says the area of the image is how many times the area of the new parallelogram. Why? So, when looking at the two areas here, what's the difference? Or how many times bigger is the bigger one we made versus the smaller one? Well, 6 times some number gives us 54. Therefore, you can fill in that blank with the number 9. So that new parallelogram is 9 times bigger. Why is this? Well, when we multiplied each of the vertices by 3, we made each coordinate 3 times larger. And when you multiply something that's 3 times larger by something else that's 3 times larger, what's 3 times 3? 3 times 3 is 9. So how many times the area of the parallelogram? We're going to put 9 times. That concludes our lesson 60. Your practice and what you need to bring to class is on page 409, and you have letters A through D.